Thank you, Rob. It's great to get an overview of some of the real-time capabilities across ArcGIS, and I want to help bring that to life with a few real-world demonstrations of ArcGIS Velocity. As Rob mentioned, ArcGIS Velocity can be used to rapidly ingest real-time data from a variety of sources. But the power of ArcGIS Velocity is then being able to analyze that real-time data to find insights, alert the appropriate teams or departments to changes in that real-time data, which can then enable an organization to act quickly and decisively. Throughout these demonstrations, I also want to consider how ArcGIS Velocity fits into your wider ArcGIS system and how results from real-time analytics can be shared across a whole organization through applications like dashboards. For our first use case, I want to consider how I can use real-time data to oversee issues on a transportation network. Organizations in the transportation industry are often under huge pressures to keep traffic flowing smoothly and, in the case of emergency events on roads, ensure the right resources are deployed quickly. To help overcome some of these challenges, I'm going to use ArcGIS Velocity to ingest a feed from Waze, a community-based traffic application. By connecting Waze data to my ArcGIS system, my transport organization can spot hazards on the road network as they occur and respond more effectively where there might be a wider event taking place. Here you can see I'm accessing my ArcGIS Velocity application inside my web browser, and I have access to all of the tools I need to get started. On my homepage, I can see my recent feeds or analytical tasks for my organization, but I also have access to the guided workflows that help me to bring in my real-time data. For my transport use case, I'm going to create a feed to ingest the data I need from Waze, covering an area in Birmingham. To do this, I can simply enter the URL endpoint for the Waze feed. ArcGIS Velocity instantly gets to work checking that it understands the data schema. For this real-time feed, however, I want to access data that is nested within the URL's JSON structure. I'm going to specify alerts as the root node from the JSON data format being delivered through this URL. You can see that I now have more information specific to the alerts registered through Waze, such as the type of road and the type of alert. I can also see I have some location information being fed through from this feed, but I want to get to the separate X and Y coordinates within that location field. Here I can choose to flatten the JSON structure to access that data. As you can see, configuring ArcGIS Velocity for your real-time data feeds is quick and easy. I can now specify those location fields and the spatial reference that ArcGIS Velocity will use to plot the road alerts correctly on my maps. I can even choose how often I want this feed to run, and it could be at a certain time of day, or in this case, I'm going to poll the URL every 10 seconds to ensure I have the most up-to-date information. Once the Waves feed has been initialized in ArcGIS Velocity, I'm able to then visualize road hazards and alerts in my web maps that I can share to my wider organization. Now you can see how a real-time feed can be created in ArcGIS Velocity. Let's now consider how we can use a real-time analytic to gain further insight for an organization interested in using real-time data. For this, I'm going to consider a scenario for a water utility. I've already ingested multiple sources of real-time data, including flooding information, sensor data from devices on the water network, and the locations of water tankers that deliver water to customers who may have been temporarily impacted by an outage. ArcGIS Velocity is going to be a crucial component for this water utility's response to issues occurring on the network, And with the help of a real-time analytic, I want to trigger different types of alerts and actions depending on what the real-time data is telling us. And here I've been able to configure that really powerful real-time analytic directly in ArcGIS Velocity that will automatically detect incidents from sensors on the water network and take the appropriate action on them. In this scenario, the real-time analytic automates a process to evaluate the proximity of external forces when a sensor triggers an alarm, including mains replacement works, road construction, and flooding areas. When an external force is found to be in close proximity, the analytic will trigger an action. This might be sending an automated text message to the closest water tanker so they can get to impacted customers quickly. But as well as sending automated alerts, ArcGIS Velocity can send data back to your IoT systems or other datasets in your ArcGIS environment. That might include sending a follow-up notice to a work order management system or sending information to public outage maps. So how can I then share the results of this analytic to my wider organization? I've chosen a dashboard as an operational tool for this water utility so they can better respond to the outages that are happening on the network. My ArcGIS Velocity analytic is feeding through my alarm sensor data in real time, but it also identified a few areas where sensor alarms came into close proximity to those external factors. For example, where a high pressure alarm was detected, the analytic found coincident mains replacement works. And as a result, the mains replacement team operating in this area were notified via email to inspect and check the network is still running smoothly. In this area, a low pressure alarm was detected in close proximity to flooding alerts. Heavy rains may have caused damage to the network and caused a leak that has knocked customers off supply. As a result, the closest water tanker to the alarm was notified via text message to get to the impacted area as quickly as possible, whilst being aware of any health and safety issues. And as I brought in my real-time tanker feed into ArcGIS Velocity, I can see the closest tanker and how far away they are from the alarm to respond. And finally, for a sensor that appears to have gone silent, I've also included that Waze data for road construction alerts, of which some is taking place near that sensor, which may have inadvertently caused damage and made it go silent. A technician received a text message to go and inspect that sensor as quickly as possible. Hopefully, those brief demonstrations have given you some inspiration for how ArcGIS Velocity could be used for a variety of your own IoT use cases.